Well, hello there. It's hot out there, isn't it? Well, it's supposed to cool down a little bit, and then I'm sure we'll get into summer and we'll be missing our spring days. So, this is lecture number 24 for CIS 41B, Healthcare Information Security and Privacy for the Practitioner, recorded on May 22nd, 2025. And as you may have already heard, my plans are to go through some networking concepts. It took me a while to get through all the network maps. There's a lot of good work in there, but I wanted to make sure that some concepts were covered that I didn't see in the network maps, or at least not in the majority of them, because networking is a big part of cybersecurity and it's a big part of being an IT professional. And this is not a networking class, but I didn't want any of my students leaving this class without having at least some of the basics that I want to see reflected in your network maps. I would hate for you to show a network map to somebody who's thinking about hiring you and it doesn't make sense or doesn't reflect at least the basic concepts. Now, network maps have mistakes on them. They can have typos. They can be oversimplified. It is a living document many times. Your network is always changing. You're always updating your map. You're always updating your inventory. You're adding devices. You're adding IPs, on and on and on it goes. So, yes, in that regards, I'm very forgiving. But when it comes to basic things like gateways and subnetting, I think it's really important that you are aware of them and have a good grip of them. So let's go through it. All right, so here's our agenda here. I'm going to revisit the OSI model. We're going to talk about some OSI hardware in that respect. We're going to talk about layer 2 and layer 3 devices, firewall, specifically managed firewalls. And then we're going to get into designing a network. We start off with something simple, simple flat network. We're going to turn it into a multi-sub network. Excuse me. Then we're going to do some routing in that network, and then add an MSP, and then MSP, and then I'm going to go through some specific project feedback, and then some final thoughts. So let's get going. So you all may know this already, but I'm going to break this down from the ground up and try to keep it simple because, like I said, this is not a networking class, but I want to make sure you're aware of the OSI model, right? This is something you're going to need if you're doing a Network Plus or a Cybersecurity Plus certification. So we have 7 layers here, and they work downwards: the application layer, the presentation layer, the session layer, the transport layer, the network, data link, which is most particular for our network maps, and then, of course, the physical layer. And so let's go through them. The network, layer 7 is the application layer. Okay, so this is our interface between the user and the network. We're looking at applications that communicate between software and the underlying network. So this serves as an interface where applications access network functionality. So this layer doesn't actually mean the applications themselves, but the protocols they rely on to communicate over the network. So HTTP and HTTPS for web browsing. For email, we have SMTP. For Zoom, we use SIP or RTP, remote transfer protocol. I think I got that right. FTP, file sharing, and secure file sharing. So each of these protocols ensures that application data is properly formatted, transmitted, received between the systems. So layer 7, of course, is essential to building applications that communicate across networks. Then we have the presentation layer. So the presentation layer is responsible for translating, encrypting, and compressing data so it can be properly understood by the receiving system. It acts as the translator between different data formats and ensures consistency across platforms. So this is where we have our TLS and our SSL, the transport layer security, and our secure sockets layer. Hypertext transfer protocol secure. It's for secure web traffic. We even have our imaging encoding here, like our joint photographic expert group, JPEGs. Our PNGs, portable network graphics, audio compression lives here in the presentation layer. MPEG, audio layer 3, and then AAC, the advanced audio coding. So, and even our UTF, Unicode character encoding, it's all as part of the presentation layer. So this data is secured here, is compressed efficiently here, is properly formatted here before it reaches the application layer or before it's sent over the network. Then we have our session layer. Okay, so the session layer manages and maintains communication sessions between devices. A session layer refers to a sustained exchange of information between two systems. And this layer handles the setup, control, and orderly termination of those sessions. So some of our examples as we have here are remote desktop protocols, our RDPs, a secure shell, which we've worked in, usually in a terminal, which both requires a login session to be established and tracked. We have session initiation protocol, which is used in voice over IP. And we have stateful firewalls, which track active sessions, states to ensure only valid traffic is allowed. We have server message block, which protocol in Windows networks, which maintains file sharing sessions between clients and servers. So the session layer ensures that applications can sustain communication over time, even in the presence of interruptions or complex interaction sequences. Then we get to our transport layer. The transport layer provides end-to-end communication, reliability, and flow control. So transmission control protocol, TCP, which provides reliable connection-oriented communication. So for example, when you load a web page over HTTPS, I should say, TCP ensures that all the packets arrive in the correct order. Very important in our internet backbone protocols. User datagram protocols are UDPs, which are connectionless and does not guarantee delivery. It's used for real-time applications like video streaming and online gaming, where speed is more important than reliability. So these two right here, TCP and UDP, very important. You need to be aware of these. They go over certain ports like TCP port 443 for HTTPS, a UDP port 53 for DNS. A lot of protocols use these transport layer protocols as part of their service. So knowing your ports as well as the transmission protocol that it goes along with that port is an important part of networking. We're not going to get into all that right now, but when you memorize your ports for your Network Plus or your Security Plus, TCP and UDP are important parts of that. All right, now we're down into what's important for our network maps. Layer 3, the network. The network layer is responsible for logical addressing and routing. It determines the best path for data to travel across interconnected networks. At this layer, the primary protocol is the Internet Protocol, IP, which assigns unique addresses to each device on a network. So for example, a workstation might have an IP address of 192.168.10.5. Routers operate at the layer 3, okay? Routers operate at layer 3. Their job is to examine destination IP addresses and forward packets between different networks based on routing tables. Another important protocol in this layer is the Internet Control Message Protocol, ICMP, which is used for network diagnostics. Tools like ping and traceroute rely on ICMP to test connectivity and measure path latency. So, to wrap it up, the network layer provides the logical framework for inter-network communication and is essential for delivering data beyond the local network, and beyond the local network. All right, then we get to layer 2, which is our data link layer, which is responsible for the local delivery of data between devices on the same physical or logical network segment. So at this layer, data is packaged into Ethernet frames, which are used to transmit information within a local area network, or LAN. Each device on a network has a unique media access control, our MAC address. So you can see an example of a MAC address there. MAC addresses are used to ensure data is delivered to the correct physical device. So every physical device should have a MAC address. All right, Layer 2 also supports virtual local area networks, VLANs, which allows switches to segment traffic logically even across the same physical network. Another key function at this layer is the Address Resolution Protocol, or ARP. And you may have heard about ARP tables and ARP poisoning as an attack. So ARPs map the Internet Protocol addresses to their corresponding MAC address. So to wrap this one up, the data link layer ensures that data is accurately delivered to the correct devices within the local network. How does it do that? By mapping IPs to MAC addresses in the ARP tables. Then we get down to the physical layer, right? As you can tell, this is all about the actual transmission of the raw bits, the ones and the zeros, over a physical medium. This layer defines the hardware and signaling methods used to carry data between devices. So we have Ethernet cables such as Cat5, Cat5e, Cat6, which are they transmit electronic signals or electrical signals. Then we have fiber optic cables, which uses light pulses to send data over long distances at high speed. All this stuff I'm sure you know. We have our Wi-Fi signals, which transmits data using radio waves. Then we have our NIC cards and switches and hubs. And these are the physical devices operating at this layer. So the physical layer is essential for enabling the actual movement of data from one device to another through wired and wireless connections. Now we're going to go into layer 2 devices and layer 3 devices and kind of drill down on these particular subjects. So for a layer 2 device, this operates at the data link layer, and it forwards traffic based on MAC addresses, not IP addresses. So in a small office or an enterprise network, their primary role is to connect end user devices like PCs, printers, IP phones even. Managed layer 2 switches can also segment traffic using a virtual local area network called a VLAN, allowing administrators to isolate traffic logically. Layer 2 switches maintain a MAC address table so that Ethernet frames are forwarded only to the specific port associated with a device, rather than being broadcast to all ports. These devices are ideal for flat networks or environments that need only basic segmentation. For a small or medium-sized business, unmanaged switches offer plug-and-play simplicity, often used in small office setups, while managed switches provide additional features like the VLAN support, quality of service, which is something you need for your IP phones, and then network monitoring. So, however, layer 2 switches cannot route traffic between VLANs or subnets. So for that, a router or a layer switch is required. So that's where we live at. That's where we probably will always live at. Layer 2 devices for managing networks, even on a VLAN, it can be cumbersome. So I'll explain that here in a little bit. But layer 3 devices. Layer 3 devices operate at the network layer. They would forward packets based on Internet Protocol, or IP addresses. So instead of using MAC addresses tied to the ARP table on a layer 2 device, they focus strictly on using the IP address to forward packets. So in an office network, their primary role is to route traffic between VLANs or subnets, making inter-network communication possible. They also commonly provide internet access through what's called NAT, or Network Address Translation. So beyond basic routing, layer 3 devices can also handle critical services like DHCP, Dynamic Host Configuration Protocol, Domain Name System, DNS, firewall rules, and even virtual private networks, or VPNs. So in a small and medium-sized business, routers and firewall appliances, such as some examples there, the pfSense, Cisco, are commonly used. So layer 3 switches combine switching and routing to enable faster inter-VLAN routing within the local network. So the key advantages of the layer 3 devices are enabling inter-VLAN routing for segmented networks, supporting access control lists, ACLs, to control traffic between departments or zones, and centralized network services like DHCP or DNS for easier management. So obviously, layer 3 devices are the backbone of a routed network. So here's our quick summary here. A layer 2 managed switch is ideal for VLAN segmentation and local device communication. It can isolate traffic between departments or roles, but it cannot route between VLANs or subnets. So when I say ideal for VLAN segmentation, that means that if you're using a layer 2 switch, you can assign the specific ports to a VLAN, but that's still managed by the router upstream. So it won't be able to go from one VLAN port, even in the same device, to the other VLAN port. It's not set up like that. It has to be done at the layer 3, and that's why it's better to just manage everything at your layer 3 router. So if your network requires higher performance and less latency, that's where we go to layer 3 switches, combining switching and routing functionality, help reduce bottlenecks, enable inter-VLAN routing. So the table here obviously summarizes this. See if we got everything here. Firewall capabilities live in the layer 3. Firewalls are layer 3 devices. So firewalls. Now, if I'm setting up a small healthcare clinic network, this is where I start. I put down the $4,000 to $10,000, whatever it takes to get a good quality managed firewall. And I probably would like it to have a decent UI interface. But some of the more higher end ones, you do everything command line interface. And it's pretty straightforward. A lot of the command line interfaces are proprietary. That's why Cisco and learning how to use Cisco routers has become a niche all in itself, because you have to learn how to program the Cisco routers. But let's get into the functions of a managed firewall. So first of all, firewall policies and ACLs between VLANs. So this defines what is allowed or denied between zones. A wide area network, a demilitarized zone, or virtual local area networks, all are managed at this firewall level, at the layer 3 level. So we can block guests, VLANs from accessing internal file servers that are on another VLAN. We can enforce segmentation and security policies. We can apply stateful inspection and logs traffic between the VLANs. We define rules by ports, protocols, source, destination IPs. All of that stuff we can do. at the very granular control level. So this also has what's called network address translation. So what a NAT allows is internal devices that use a private IP address, like 192.168. something, to communicate with external networks by translating those IP addresses, those private IP addresses, into the organization's public IP address. So, for example, devices across a VLAN can share a single public IP address when accessing the internet. Let me just kind of talk about that. So, when you hit the firewall, you hit the firewall from your own IP address. When you leave the firewall, you leave the firewall to go out to the internet and you're identified by the public IP address that your ISP has provided you. If you're using a VPN, that could be a different IP address based on the VPN that's set up on, and that differs depending on how the VPN is set up. But in most cases, when you go out to the internet, you're using a public IP address that's been assigned to you by your internet service provider. That's what NAT does. NAT takes you from your internal IP address and puts you out there based on a public IP address. So a lot of that is called port address translation, where multiple internal hosts are mapped to a single public IP address using different port numbers. So NAT is essential for managing secure and scalable internet connectivity across segmented networks. Managed firewalls also handle your DHCP and your subnet management. So dynamic host configuration protocol across multiple VLANs and multiple subnets can all be handled by a managed firewall. The firewall can create separate DHCP scopes, maybe for each VLAN. So, for example, we could assign 192.168.30.x addresses to guest Wi-Fi VLAN. So we could set up a VLAN that is exclusively for guests who log into the Wi-Fi guest network to assign them specific IP addresses, and then we can manage those logins differently than we could manage other logins within the network. Okay, so DHCP services can be tied directly to VLAN interfaces on the firewall, allowing it to act as DHCP servers for each network segment. Advanced features like DHCP reservation for specific devices, DNS relay, configurable lease times are all supported here, this particular function. Centralizing DHCP on the firewall improves control, reduces configuration complexity across the network. Then we have our inter-VLAN routing. This has to happen at the layer 3. As I was explaining earlier, you can have a layer 2 switch that can assign VLANs to specific ports, but the actual VLAN routing has to be handled by your managed router. In this case, we're using a managed firewall, which also handles our routing. Okay, so firewall can enable devices in the staff VLAN to access resources in the printer VLAN. The firewall achieves this by assigning interfaces or sub-interfaces to each VLAN and performing layer 3 routing between them. It also applies ACLs, access control lists, or firewall policies to control what traffic is allowed. So this ensures that communication between VLANs is secure, intentional, and policy-driven. Right? So this is where we live as cybersecurity professionals, right? We want our VLANs because they help us provide security. Everything that goes through a VLAN is intentional. That means we are allowed it to happen. We want it to happen. And it's policy driven. So it's based on our administrative controls that have been handed to us so we can roll out the technical controls to enforce the administrative controls. All right. All this stuff you know, but here is the trick. We want to do it most simply in a managed firewall. Right? Have I said that enough times already? Managed firewall. All right, wireless network segmentation. Again, managed firewalls can be a big tool in this. So we can segment wireless traffic using our VLANs tied to a specific SSID, right? What is our SSID? That is our identifier for our wireless network. So a business may assign corp Wi-Fi to VLAN 10 and guest Wi-Fi to VLAN 30. So each SSID operates as a separate virtual network, allowing the firewall to enforce different policies. So this setup requires VLAN-aware access points, which tag wireless traffic based on the SSID. The tag traffic is then routed appropriately to the firewall. With this approach, you can isolate guest clients, block communication between wireless users, or even limit bandwidth per SSID. It's an effective way to enhance security and performance across networks. If you're on campus and you're logging into the guest account over there, and you go to a browser window, and you have to put in your MVC or your Riverside username and password, you are being assigned an SSD tag as you log in. So it knows exactly what network you're using and what permissions you have, where you can go, what you can do while you're in that wireless network. All right, VPN gateways. This is another important factor here. So what this is a VPN is a virtual private network. And it provides a gateway to this virtual private network, which provides secure remote access to internal network resources. So for example, remote staff can connect to the network over a VPN tunnel and gain access to resources in VLAN 10, such as an internal file server or application. Most managed firewalls support IPsec or SSL VPNs, both of which provide encrypted communication over the internet. Again, you can drill down these on your own, but you do need to know what these are if you're going to do your Network Plus or your Security Plus. The firewall can restrict which VLANs, by VPN users are allowed to access, enforcing the principle of least privilege. In some cases, VPN clients can even be placed into their own isolated subnet or dedicated VLAN, such as a VLAN 50 for enhancing control and monitoring. So this functionality is critical for supporting secure telework and third-party access in a segmented network. So the bottom line is you log in to your network remotely using a VPN software sometimes, maybe through a browser access. And once you log in, it knows exactly where you're allowed to go using that VPN access. What else does it do? It encrypts your communication from your device to the network. So all of that information that is traveling through the VPN is encrypted, and usually by IPsec. All right, and then we have intrusion detection and logging. Okay, so managed firewalls have some IDS functionality. So firewalls can monitor and inspect traffic moving between VLANs as well as outbound connections to the internet. So it can detect and alert on suspicious behavior, such as port scanning between internal VLANs, connection attempts, including those that were blocked, are logged for auditing and analysis. Many firewalls support integrated intrusion detection or prevention systems, right? IDS or IPS, Snort, Cicada, to identify known threats. So these logs can be forwarded to a security information and event management system, a SIEM, and allowing centralized analysis, alerting, and compliance reporting across the entire network. So we have lots of power with a managed firewall. So why have anything else if you're going to be running a small business or a small network? You can do a lot right here with your managed firewall. The functions are tremendous, and you get a lot of bang for your buck. And it's all in one place. So you don't get too much of a variety of devices all kind of maybe starting to conflict and stomp on each other. If you can get it all managed through your firewall, that's the way to go. Of course, if you get into a larger organization, you're going to find yourself in a much different situation. But for even your own home network, get a cheap firewall. Play around with it. Right? Don't use that stuff that Frontier or Spectrum sent you. That's all locked down anyways. Get yourself your own little firewall. Just use their modem. Start segmenting your home network. If you truly want to get a grip of this stuff, you got to get in there and do it. There's the summary table. No need to go over there now. So when it comes to managed firewall, um, here are some examples of some pretty good ones. The Juniper SRX, that is a high-end command line interface only. And it comes with subscription. And I think that's become a new business model for these firewalls, is that through a subscription service, they can provide a lot of features and a lot of monitoring that you may not be able to do yourself. So there's a lot of positives to having a subscription, especially if you are a very small staff. You know my view. Leverage your third-party vendors. And if you can afford a subscription service, make use of it. Fortinet has one. Now we have the pfSense. The GUI is not that easy. We actually have pfSense in our lab environment. I don't know if any of you have gone into the actual firewall and tried to mess around with it. I went in there and broke it a few times. But it's there if you want to take a look at what that interface is. And yes, it's a GUI, but it's not that easy to use. Then we have our Cisco Firepower 1010. All right, expensive, enterprise level. It's a whole nother niche. You want to be real valuable and work at a big, large organization level, or for a network internet service provider, then get your Cisco certification. That's a path you're eventually going to follow. All right. Let's see here. Did I get my things out of order? It looks like I got I just got my title wrong here. This should be Flat Network Part 1. I'll fix that before I put this up there. Okay, so when we build a network, or when we find ourselves in an organization that needs help figuring out what it's got on its network, what its devices are, I highly suggest that you work backwards from your firewall. You identify your firewall, you learn it inside and out, you read the manual, you read the spec sheets, you take a good look at all the ports, you understand that device. That is where you're going to start. And then from there, you kind of work yourself backwards into the network. Now, when designing a network, or when you're trying to at least get a grasp of one, keep your very first map simple. So I think that for a lot of these network maps that I saw, there was a tendency to kind of like put a lot of stuff in there and just kind of see if you could make it work. My suggestion is always to start at the very basic level. So what we have here is a very basic flat network, right? So we're using a single subnet. So our subnet, as you can see there on my table there, and let's quickly talk about CIDRs, a classless interdomain routing. That's a way to indicate what the network is that you're using, right? So in this case, I'm using a 192.168.1.0/24, right? So I'm using a /24 network, and the network address is .0, The broadcast address is .255. So those cannot be used, right? So 255 is to everybody. 2.0 is for network address. So those cannot be assigned to anything. Now, I would note here that I have an old school approach where I like to use .1.0/24. I like to build from that particular um, network address because yes, you can use a .0.0/24 and it's perfectly fine, especially at this level of networking. But when you get up into the real big networks and probably huge, um, .0 is still a reserved, in that third octet is still a reserved um, network address. So just by habit, I like to start at .1.0. Nobody's going to get marked off any points if they decide they want to go .0.0 down. Okay, so I've established what my CIDR is. Now I want to assign my IP addresses. And the first one is my firewall. So my managed firewall is 192.168.1.1. What is that also? That is the gateway for this particular network, right? So for a gateway to happen, we need to assign it based on the subnet that it's part of. But when we're in a flat network, the IP address for your firewall is pretty much going to be your gateway. Okay, so they're synonymous in a flat network that has no subnetting. Okay, and then I've got a switch, and I like to call my switches .2, right? So right off of the firewall, it's .1, .2. And then I've got 3 computers connected to it. And in this case, I'm starting my workstations at .10. So I have .10, .11, .12, right? So this is all static. It's a static assigned. If you're going through the labs, that is what you need to do that I didn't show you is you need to assign your IP addresses to that server that I think it was the database server. So that's what you're doing. You're assigning an IP address, submask, and a gateway. As you can see there on our network diagram, the gateway for every workstation is the IP address of our firewall. The gateway for our printer, which I've assigned a .1.100, because I like to have my devices start with 3 digits, have a 3-digit. You can do whatever approach you want. That's my approach. So my printer is 100. My file server, which I've connected directly to the firewall, is 200. So the firewall is managing all the routing for this flat network. Okay, so as you may have noticed on that network map, I do have my ISP here. So this is my public address that we talked about earlier that the NAT function of the firewall will use to show as the source of where we are from when we traverse the internet. And it has its own gateway there, and it has some bandwidth. We have our own DNS. We have a public DNS or the ISP's DNS. We have Google here, I believe, is 8888. So there's the gateway. This is all stuff that's provided by your ISP provider. So your firewall has what's called a WAN interface, right? This is the wide area network interface. So that is where you're going to put this information in. Then you set up the LAN interface. This is everything that connects internally. So this is where you set up your internal IP address for the firewall, which is 192.168.1.1. Subnet mask is 255, 255, 255.0. We don't have a gateway because we are the gateway, right? Then you could set up a DSCP server, forwarding, all that stuff we're going to talk about here, but these are options as we set up our LAN side of things. Okay, now let's get into that a little bit more. Now we want to take our basic setup and let's expand on it. And in this case, we're going to expand on it by adding a Wi-Fi device that all of our mobile laptops can connect to, right? So what I've done is we're still on a flat network. So the IP address here is 192.168.1.50. I chose that for a variety of reasons, but in this case, it just is to set it apart from the rest of the network. So my IP address is 1.50. Then we have our DHCP mobile device pool. So the DHCP is managed by the firewall. So in order to set up a pool of DHC devices, it has to be managed by the firewall. So in this case, DHCP mobile device pool. So these devices will be set up as DHCP devices. And then when they log in through the Wi-Fi, it will see it as a DHCP device and then assign it a IP address within this particular range that I've set up here, 51 to 99, right? So they still all have the same gateway, but they are, when we set them up, we're not setting them up as static IP connections. We're setting them up as DHCP connections. So we just kind of grew the network a little bit here. We just added a access point and we assigned it an IP address. Then we have, in this case, 3 laptop devices, which are set up as DHCP. And when they log in, they get an IP address assigned to them from the firewall for its connectivity. So once it gets logged in, then it's got an IP through a DHCP, and it holds on to it until it turns off. Okay, so now that we've kind of have a basic network, let's subnet our network. And this is where I think some of you kind of fall off a little bit. And so I want you to take the time to go back through your network map and consider how to subnet things, right? So we want to subnet things many times by functions. So we'll have servers be on one subnet. We'll have our wireless devices on another subnet. We have our wired clients on a different subnet. And for those who are really good at subnetting, this is where you might use something like a /25 to kind of limit the number of IP addresses within a subnet. At this stage of the game, I would just recommend keep all of your subnets /24. So you've got a consistency across all your subnets. You know that you have certain IP addresses that are reserved and some that are not. So let's kind of go through this real quickly. So I kept the original flat network IP address structure for my workstations, my switch, and my printer, but I've turned them into their own subnet. So if you see there, they have subnet 192.168.1/024. That's the original flat network. And it still has the same gateway IP address, which is the same as the firewall IP address, right? So all of that is still the same. But I have to set that up still as a subnet within my firewall. Then I have a second subnet, which is 192.168.20.0/24. And the gateway for that one is 192.168.20.1. This gets set up in your managed firewall. So when you set up your subnet, you are assigning what the CIDR is, and then you are assigning what the gateway is. Then your devices have to reflect that if they are in that subnet. So in this case, our wireless device now has an IP address of 192.168.20.50, reflecting that it's within that subnet. Submask is still the same because the 3255 say use the same thing as the IP address. Then our gateway is the gateway that we set up for the subnet, right? So in this case is .20.1. Then our DHCP mobile device pool, the scope is also changed to reflect that it is on a different subnet. And the gateway IP address reflects the subnet it sits within. So as long as you have all of this lined up correctly, everything will work within that subnet. And when it needs to connect to another subnet, the managed firewall, if it's set up correctly, will know what subnet to forward the information to. Right? So if someone on a laptop needs to get access to the printer, it knows where the printer's at and can send the print job appropriate. Then we have a subnet for our server. Now, in this case, I just have a basic file server, but I added a switch because let's face it, you're going to have more servers, and I didn't really go into depth about adding more servers here, but this is where you might put your backup server. I've kind of mentioned that in your feedback for a few of you people. This is your backup server place. You would go ahead and add it here. In this case, I've got a file server where we kind of go ahead and get extra files. Maybe we're backing up to this file server, whatever might be the case. But this file server reflects the new subnet. So this subnet is set up on a .10.0/24. And the gateway is .10.1. Our switch is 10.2, similar parallel to what I did for the original flat network, which I had 1.2. This one is 10.2, and its gateway is 10.1, reflecting the subnet gateway that was set up in the managed firewall. And then, of course, our file server has the same gateway, .10.1. It sits on 192.168.10.200. Okay, so take a moment here. This is what I want to see on your network maps. So if you've got a network map that's got a whole bunch of devices on it, if you've got a bunch of printers and you've got a bunch of workstations, you have a wireless network, I want you to take a good look at that, try to simplify it a little bit, and then break those into their own subnets, all managed by a firewall. All right, does that make sense? If it doesn't, reach out to me and we'll walk through your network map together. Now, like I said, I just want your network maps to look and reflect your knowledge of basic networking. And this right here is a big part of it. Okay, so then we could move on to our table. So I know I only asked you to do the actual network map and add the IP addresses to the network map. But if you really want to do it right, you should have an IP table that goes along with your network map. And one of you has actually been working on that, and I'm very, very pleased to see that. So keep working on that, organize it a little bit better, get your subnets reflected in the IP table. For the rest of you, don't be afraid to add one in there. So here is a basic network IP table for that segmented network. So we have a switch 2 in a file server, and it shows there that it's on the subnet that we've listed above there, server subnet, which is our .10. And then we have .10s here. Then we have our wireless access point, which is on .20, .20 there, 51 to 99 is our managed firewall. And we see here that our DHCP server is managed firewall, right? I'm going through this thinking, did I make a mistake? Because yes, it's going to get complicated. This is only where we've gotten to our like a second layer here. Now we're going to add phones, and we're going to talk about VLANs a little bit. So Nowadays, IP phones have become the standard. And there are a lot of different ways to manage your IP phones. What I've put here is the most simplest and basic way, and that is to put them in their own subnet. So I added a subnet, and you'll see it down here. I didn't want to put it next to the firewall. I wanted to make sure that it was clear that it was part of this phone setup down here. So I added a new subnet called assigned .40.0/24. And this is specifically for my VoIP devices. So I put a switch on it. And as usual, I did a .40.2 for this particular switch. And the submask is the standard submask. The gateway is .40.1. So any traffic going out will go to the managed switch, the managed firewall, which is a managed router. It's our all-in-one device. It makes things simpler. Believe me, it's the way to go if you find yourself in a network situation. Um, that doesn't mean you're going to find yourself in a network where someone has decided to use a managed layer 3 switch, and then you have a basic firewall that's between the switch and the internet. That happens all the time too, as well. But for a lot of times, if you have the option, you can do it all in one place. That helps to make sure that things are set up correctly. You don't get any conflicts between your switch and your firewall. All right, that's just my pitch. Every organization is different. Your goal is to learn how your organization works. In this case, I have put all of the VoIP phones on their own subnet. And I have a VoIP controller. So whenever you have voice over IPs, you're going to need a server that handles the management of those phones. And a lot of times it has to do with it connects to a VoIP provider. So if you see there at the top, I've got myself a small dotted line there that represents the outbounds SIP trunk, which we talked about earlier, as being a voice over IP protocol. So it goes straight to the provider through the internet. It goes out through our internet provider, but it's got a VPN approach to it. That doesn't always happen. Sometimes you'll get a T1 that is specifically from your VoIP provider. It's a hard line that goes right into your office and then connects into your VoIP controller there. Sometimes that happens, so sometimes it'll sit outside. A lot of times, though, it goes through your managed firewall. And quality of service types issues are handled by your firewall. Then your DHCP IP phone pool is also handled by your managed firewall. Now let's talk about VLANs. In the managed firewall, you can assign a VLAN to a subnet. And when a VLAN is assigned to a subnet, it's assigned then to specific ports by the switch. So without getting this too complicated, usually when you roll out a VLAN, you're going to roll out a VLAN for every subnet. In this case, in this basic illustration, I'm only rolling out one VLAN for my IP phone pool. So if you see there, one of our points there, label ports 1 through 12 on switch S03. So this switch is a layer 2 switch, but layer 2 switches can assign ports to be on a specific VLAN. So you have to go in and log into your switch many times through a command line interface, and you have to assign the port to the VLAN. Then the managed firewall will be able to manage traffic through those VLAN ports. So if it has a phone call, let's say from one IP phone to another IP phone, The data will traverse the layer 2 switch up to the managed firewall. The managed firewall will see that it's internal and then manage it back down through to the IP phone, all with the IP controller in the middle of it. That's as deep as I'm going to go on it. I am not a VoIP controller specialist, uh, but that's how that is handled, right? So even if these were VLANs, it's the same thing. For let's say our workstations were VLAN ports. Let's say we had VLAN 01 to go along with subnet 1. These VLANs then would have hardwired ports. So each one of the ports that each one of these computers plugs into would be assigned VLAN 1, but it would still be managed by the firewall. In this case, they can actually communicate to each other within the layer 2, but usually we go to the firewall to get to another network. That's the whole gist of the layer 3 routing. All right, so we have simple routing on the layer 2 switch. It can quickly see that it's right there on the same switch and connect. But if it has to go to another subnet, it goes up to our managed firewall. All right, so that's the basics of a VLAN. I'm not requiring you to do VLANs, but I wanted to make sure that you knew that concept because it's become very important and often is almost commonplace that every time that you create a subnet, you create a VLAN that parallels it. And this just is another way to segment your network, right? Network segmentation is critical to defense in depth in cybersecurity. So putting all of our most important things into a VLAN that is on a subnet that can have another internal firewall protecting it where it only lets 1 or 2 ports open is all part of defense in depth and network segmentation that you should all be aware of as cybersecurity professionals. All right, so then we have our table here. So I've added that particular CIDR, which is a .40/24, the network address, the broadcast address, and I indicated that's VLAN 40. So anybody that's on this network has got to be, I guess hardwired is a correct way to say it, to a port that is assigned VLAN 30. And that's what we have down here for our switch 3. It's a VLAN 40. It connects via a VLAN 40 port on the managed firewall. The VoIP controller connects to a VLAN 40 port on the actual switch. All of the phones that connect to the switch connect via a VLAN assigned, VLAN 40 assigned port. All right, so that's pretty much it for VLANs. I just wanted to make sure that you were aware of that concept and that it is the key point there is that the port is assigned to be on VLAN 40. If it has not been assigned within the switch or within the managed firewall or the managed network switch, it will not work. It will not communicate. That is the strength of the actual security around VLANs. Okay, last, we add our MSP. So our managed service provider, in this case, my example is Athena Health, right? So we have this small healthcare network, and we're going to leverage again a third-party vendor to handle all of our electronic protected health information. But how do we connect to that MSP? And we could connect to that through an encrypted VPN. So I've added to this network map an encrypted VPN IPsec using AES 256 encryption to connect to our EPHI server, or in this case, our managed provider. So They have their own gateway, which is given to us there. So the firewall, whenever one of our employees needs to update electronic health record, they are using the interface that goes out through the switch, through the managed firewall. The managed firewall recognizes the MSIP gateway, puts it over the encrypted VPN, and goes to the MSP that way. All right, there's a lot more depth to that, but the firewall handles VPN connections. That is an important point there. So if you wanted to have your CEO be able to log in through a VPN, this is where it would be handled. This is where it would be set up. And then on the managed firewall side, you can dictate where the VPN has access to. So for example, for our MSP, we only want the workstations to be able to connect to it. Maybe we'll just assign only subnet .1.0/24 can access the MSP for electronic health information. So that can all be managed in our managed firewall. Okay, so that's the general idea of building a network map and just the basics that I'd like to see reflected in your network maps. These next few slides are going to focus on some general feedback for all of you. I kind of took all of the individual feedback that I gave to you for your network maps and I consolidated them. And this is what I came up with. And I want to make sure that I cover each one of these in a general sense. So first of all, we have IP addressing and subnetting, which I've kind of gone through already. Let's just drill down to some basic concepts. So all IP addresses must use 4 complete octets. All right. So I noticed some people only had 3. Sure, it's a typo. Wasn't meant to be. Remember now, there are 4 IPv4 structured octets. All right. Then avoid using a leading 0 in an IP. So don't use like a .031. Because that can kind of mess things up. It just doesn't read correctly. Right? You just want to use .31, not 031. Then be very careful about mixing up your IP addresses. You know, it should be 192.168.1.250, not 192.1. Whenever it comes to computers, programming, networking, all of these things matter. You could be pulling your hair out for hours if things aren't set up correctly the first time. Okay, also 192.168.1.0 cannot be assigned to a device in a 24 subnet, right? It's reserved as a network address. So .zeros are reserved. Can't use them. Be very careful of duplicate IP addresses. Each device must have a unique IP address. One of the most interesting things in networks that in companies that I've worked in and had to manage is IP conflicts, and they happen more often than not. And sometimes it has to do with mismanaged DHCPs. Sometimes it has to have like a static assigned IP address. I remember one time I had a static assigned IP address that was within a DHCP. And then when I got into the office and I logged in, I couldn't go anywhere because a DHCP computer had grabbed that IP address. So keeping all of those IP addresses clearly segmented, whenever you're going to assign a static IP address, they should definitely be outside of a DHCP pool. So that is that particular situation. When assigning static IP addresses, obviously 2 people can't have the same duplicate IP address, or it's just not going to work. Also, you must include the subnet mask or the CIDR notation and the default gateway. So I've noticed that was kind of a big thing on a lot of network maps. I was not seeing default gateways. I showed you that before. That's something I'm going to mark points off on if I'm not seeing it on your network map. And then be consistent in your gateway addresses. Usually dot one is where you want to be for all subnets. A quick visit on IP, private IP ranges. Here we have a class A, which is a 10.0.0.0/8. This can have 16.7 million IP addresses under it. 172.16.0.0/12. This has up to 1 million total IP addresses. And those are the ones that I think make me nervous when we're running a 192.168.0 network. Um, you can do that in a 192.16.0, but you have to be careful about it. So in a 192.1.62, it's perfectly fine. I just avoid it, and you can see the range there. So these are your private IP address ranges. If you're running a small health care clinic, there's no reason why you can't use the Class B if you wanted to. But for all of us who are like getting our feet wet and getting networks designed for the first time, stick with your Class C, 65,000 IP addresses. You can segment it across all of those, from .0 to from 255. Why not? All right. Okay, so subnetting and VLAN design. I talked about this already in the basic design, but just to revisit it, you want to you want to segment the network by functions, all right? So your subnets should be logically designed by function. So you have your workstations and your desktops on one subnet. You have your servers on another subnet. You have your Wi-Fi devices on another subnet. Maybe your guest Wi-Fi logins on another subnet. Your IP phones on another subnet. Your proxy server, your EHR, your mail servers, your DMZ, specifically your DMZ should have its own subnet. So have some logic in how you break down your subnets. I'd like to see some subnets in your network maps. Um, it's not that hard. I've walked through them. Show me that you know how to do subnets on your network maps. You should use VLANs to further isolate wireless phones, guest traffic. I'm not requiring a VLAN. If you want to put a VLAN in there, I will note it and I will take a moment to consider more credit for your network map if maybe I'm knocking off points somewhere else. Use non/2524 subnets. Avoid that unless you fully understand their limitations. I saw some people using /25s. If you know what you're doing there with a /25, you have my permission to use it. I will drill down on it to make sure you're using it correctly. My suggestion is stick with /24s, get comfortable with them. It gives you everything that you need, and you don't have to start computing network bits and what a 24 is versus a /23 and on and on. Include and label the DMZ clearly. So I know that some of you had subnets that did have a DMZ, but we're kind of still on a flat network. If you're using a DMZ, please make sure that that's clearly labeled. Show me some VPNs. If you are connecting to a cloud service in any way, I'd like to see it connect over a VPN. If you're using a managed security service provider over a VPN, if you're using an electronic protected health information client or provider, I'd like to see it connect over a VPN. Show me a VPN. You're going to need to know how to use them anyways. Label firewall roles clearly. So this is something that is not necessary. If you were at a graduate level class and you had a managed firewall, showing your firewall rules would be needed. In this case, I'm not going to ask you to do your firewall rules, but if it's a perimeter firewall, label it such. If it's an internal firewall, label it such, right? backup servers or backup strategies. I like that. I really would like to see a backup server, or if you have a file server, indicate that it's a backup server as well. Whatever might be the case, let's see if we have backup servers on premise. Um, Proxy servers. A couple of you use proxy servers. I'm very impressed by that, actually. There are a couple ways to do a proxy server, and let me quickly mention that if it's on its own subnet within your network, then you have to realize that the DNS that's set up for every computer has to go to the proxy server first before it goes out to the internet. And that's either before the managed firewall will put it there and then send it out to the internet. Um, a much simpler way is to put your proxy server between the firewall and the internet. So if you're using a proxy server, that is my suggestion for a simple network map, is that you have it, um, all of its proxy um, um, functionality would be outside of the firewall. So the firewall would send it to the proxy server then would send it to the internet. I don't want to get into proxy servers here. It's a little bit beyond the scope of this class, but if you have one, consider those two scenarios and you decide how you want to do it. All right, then I like to see servers labeled clearly. If it's a file server, email server, electronic health record server, please label them. And lastly, I'm all about being professional about your presentation, making this final document, preferably a PDF document that can easily be shared with me, your teacher, easily be shared on your profile website. If you are looking to get out there and get a job, you want to be able to show your knowledge base. My hope is that you would be proud of this final presentation. So in order to be proud of it, I really want to see some simple things. I want to see that your network map has IP addresses used correctly. I want to see that there's devices labeled correctly on there. I want to see the network map fit onto one page. Some of you like had network maps thrown across a couple pages. Get it to fit onto one page. I also noticed that there are some people using some free versions of some network map tools that I wasn't familiar with that put their logo on the page because it shows this is a free version logo. There's no need to use a version that puts a logo on your page. I would avoid that. I'm not going to take off points for that, but I would avoid that. Lucid Charts, all those network maps I made, they were made in Lucid Charts. I banged them out in just less than, I don't know, maybe it took me 8 hours. But Lucid Charts doesn't put a logo on there. You all have access to Microsoft Visio. Learn that skill. There's no reason why you shouldn't be able to put Microsoft Visio as an application you're familiar with on your resume. It's available to you as students. Go use it. Okay. All right, some final thoughts here. Segment your network by function, right? I think that that's an important final thought there. I want to see segmentation by function. Make sure every IP address is valid and complete and unique. Recognize that firewalls do more than block traffic. A managed firewall is your friend. It will be your layer 3 switch. It will be your IDS detector. It will be your DHCP handle manager. It will handle all your VPN tunnels. Managed firewalls are where things are at nowadays. Label everything clearly, right? Including your IP addresses, your subnets, your gateways, your VLANs if you use them. And then security and scalability start with a good design, right? So that's what I really want. It's a good, solid design, very basic, but it's totally functional. And if I rolled out a network based on your IP addresses and your layer 3 subnetting managed by a firewall, then it should work. So that's what I'd like to see. All right, that's it. If you have made it this far to the very end of this lecture, thank you very much. I will share with you, and I'm going to make an announcement here soon, um, that the final project, which was originally due on June 2nd, I am going to push that back a week, to June 9th, which I believe is the Monday of finals week. And then the final exam itself will be Tuesday through Thursday, like I usually do for the exams. And it's just only fair, because some of the parts, the deadline got pushed back a week, and I wanted to still give you enough time to put together the final accumulation of all the parts. And I'll put out the specs for that final project submission here very shortly. But I wanted to give you a heads up that it will be due a week later than originally. The other reason why I'm giving you an extra week is because I really, really want you to put together a good professional document that you can be proud of, that you can refer to, that you can share as part of a portfolio. So it also makes sense to give another extra week to make that happen. Of course, then on my end, I'll have a lot more grading to do as I push up towards my deadline to get all the grades out. So, that's my problem, not yours. I really want you to take advantage of these extra 7 days to put in a really good um, final individual class project of a security plan for your small healthcare clinic. All right, so that's it. That's the end of this lecture. Thank you very much for watching it all the way through to the end. I hope you're having a great evening or a great day, whatever context you're watching this in. And I will see you next week. Bye.